Hello guys, I'm Karthik SP from SPC, and today my subject is Big Data Analytics, and the subject code is 21CS71, and the subject title is HDFS Basics, and my ISN is 76. So let's start. Hadoop Distributed File System. HDFS is designed to reliably store and stream very large datasets at a high bandwidth. It distributes storage and computation across thousands of commodities servers in large clusters, allowing for economic scaling. This paper describes the HDFS architecture and reports on its use at Yahoo and manages 25 petabytes of enterprise data across 25,000 servers. HDFS architecture overview. HDFS has a master-slave architecture. The NAM node is the master that manages the file system namespace and regulates access to files. Data nodes are slaves that stores and retrieves blocks of data. Files are split into large blocks, typically 128 MB, which are stored in data nodes. The name node executes file systems, namespace operations, and determines the mapping of blocks to the data nodes. Data nodes handles read and write requests from client and performs data block creations, deletions, and replication upon instructions from the name node. Name node manages file system namespace, regulates file access, determines blocks to data node mapping. Data node stores data blocks, handle read by write request, perform block operations. Name node operations. The name node stores metadata like namespace hierarchy and block locations in memory for fast access. Records persistent checkpoints and journals of namespace changes. During startup, it loads the latest checkpoints and replaces the journal to recover the namespace states. The name node is a multi-threaded system that handles client requests concurrently. To optimize performance, it batches multiple transactions when reading to the journal. Startup the load latest checkpoints and replay journals. Normal operations handle client request and namespace changes. Checkpointing periodically creates new checkpoints. Data node operations. Data node stores each block as two files in their local file systems, one for data and one for metadata. They connect to the name node as at startup to perform a handshake, verifying namespace ID and software versions. Data node then registers and periodically sends blocks, reports, and heartbeats to the name node. Heartbeats confirms data node health and carries storage statistics. The name node responds with instruction like replicating or deleting blocks. Data node also runs a block scanner to verify data integrity, such as startup, handshake and registration. Normal operations, blocks, reports, and heartbeats, block management, replication and deletion, integrity checks, block scanning. HDFS client and data flow. HDFS client provides a file system interface for applications. For it fetches block location from the name node and reads directly from data nodes. For it gets data nodes location from name node and reads directly to a pipeline of data nodes. The client computes checksum for data blocks. HDFS uses a rack-aware replica replacement to maximize data readability and read by write performance. The default policy places the first replica on the same rack as the writer, and second and third on a different rack, and additional replica randomly. Read operation. Client reads directly from data nodes after getting block locations. Write operation. Client writes to the pipeline of data nodes and after getting locations. Replication and fault tolerance. HDFS provides fault tolerances through data replications. Each block is typically replicated to three data nodes. The name node constantly monitors data node status through heartbeats and re-replicates block from nodes that fail to or become disconnected. Also balances replica replacement across the clusters. HDFS includes tools like block scanner to detect and repair corrupted data. For disaster recovery, HDFS supports multiple name nodes and cross-cluster of replications. These mechanisms ensure high data availability and durability despite frequent node failures in large clusters. Replication. Typically, three copies of each block. Re-replication automatically replace lost replicas. Balancing spread replicas across clusters. Integrity detect and repeat corruptions. HDFS at Yahoo. Yahoo operates large HDFS clusters with up to 4,000 nodes each. A typical node has two squad core processors, 16 GB RAM, and 4 TB of disk storage. Cluster stores 25 petabytes of data across 25,000 servers total. HDFS handles millions of files with 2 million new files created daily. Key applications include web indexing and user behavior analysis. Yahoo has addressed challenges like name node scalability, resource sharing, and data durability. Benchmark shows read by write speeds of 66 MB and 40 Mbps of node respectively. Yahoo sorted 1 petabyte of data in under 17 hours under HDFS and MapReduce. Nodes per cluster up to 4,000. Total storage 25 petabytes. Total servers 25,000. New files per day 2 million. Read speed of 60 Mbps per node. Write speed at 40 Mbps per node. Future work. The HDF teams at Yahoo is working on several improvements. This automated name node failover using Zookeeper for high availability, name node scalability through federated namespace and block storage abstraction, support for simpler files and application-centric namespace, better multi-cluster cooperation and replication, scaling to larger clusters while maintaining manageability. These enhancements aim to improve HDFS scalability, availability, and flexibility to support diverse use cases and larger deployments. High availability, automated name node failover, scalability, federated namespaces, small files, better small files support, multi-clusters, improved cluster cooperations. So this is the end of the slide. Thank you. Have a nice day.